Welcome to Day 3 lecture for Open Cloud Platform K-PaaS Specialist Training. Objectives for Day 3 is to let the trainee be able to deploy Container Platform Cluster, deploy, and understand the core functions of Container Platform Portal, Pipeline Service, and Source Control Service of K-PaaS. Table of Contents. Day 3 consists of 4 chapters. Deploying Container Platform Cluster, deploying Container Platform Portal, deploying Container Platform Pipeline Service, and deploying Container Platform Source Control Service. Section 1. Deploying Container Platform Cluster. Part 1. Cluster Installation Preparation. First, let's understand the process of installing a cluster with the K-PaaS Container Platform Installation Guide. You can find the guide documentation on our GitHub page. Starting with K-PaaS version 5.5, we support standalone deployments based on KubeSpray. In Section 1, you'll learn how to install Kubernetes native using KubeSpray, which is required for installing a container platform deployed on K-PaaS. The System Configuration Diagram. The container platform consists of a Kubernetes cluster environment consisting of a master node and worker nodes. To configure a Kubernetes cluster environment, you are required to have at least one master VM and at least 3 worker VMs. The container platform deployment flow is shown in the textbook. First, we install a Kubernetes cluster through KubeSpray. Next, provide middleware environments such as databases, private registries, etc. through pods. Deploy the Container Platform Portal environment on the Kubernetes cluster as a container image. Starting with version 1.4 of the Container Platform, storage is deployed with cluster deployments. NFS and RUCSF, providing 2 options. First, NFS deployments require an NFS server to be installed first. NFS clients are then pre-installed on the deployment nodes, and provisioners are automatically deployed. Second, RUCSF utilizes worker nodes rather than separate storage VMs for deployment, so each worker VM must be allocated additional volumes in addition to the root volume first. Let's take a look at the requirements for installing a container platform cluster. The textbook and GitHub guide documentation is based on installing an Ubuntu 20.04 environment. To install KubeSpray, Ansible version 5.7 or later, Jinja version 2.11 or later, and a Python net address must be installed on the machine where you want to run Ansible commands. Other key software and package version information required to install KubeSpray is shown in the table below. We will install these software and packages sequentially as per the guide. There are a few recommendations when deploying a container platform. First, you must have at least one machine running a Linux OS that is compatible with the Debian and RPM packages, meaning you need an environment with Ubuntu or CentOS installed. Those machines should have at least 8 GB or 16 GB of RAM per machine. The machine you use as the control plane node must have at least 2 or 4 CPUs. There must be full network connectivity between all machines in the cluster. Please keep these points in mind as you prepare to install your cluster. Please refer to the table shown for the container platform firewall information. The next step is to create and deploy SSH. For a KubeSpray installation, SSH keys must be copied to all servers in the inventory. We'll use an RSA public key to set up the SSH connection. Before proceeding with the steps, it is important to note that all installation processes after SSH key generation and deployment must be performed on the master node. First, enter the command to generate an RSA public key on the master node. Next, copy the public keys of the master node and worker nodes to use. The public keys will be shown when you enter the command below. Copy the shown public key. Finally, paste the copied public key at the end of the authorized key file for the master node and worker node you want to use. Add them to the bottom line of the existing file, as shown in the screenshot. At this point, you're ready to install your cluster. Part 2. Cluster Installation. Note that this step only needs to be done on the master node. First, download the source files required to install KubeSpray by following the link in the textbook for cluster installation. Then place them in the KubeSpray installation path. Next, use the git clone command to download KubeSpray from the following path. The installation guide is based on KubeSpray version 2.20. Let's take a look at preparation steps to install KubeSpray. In this step, we'll predefine the necessary environment variables and then run the installation through a shell script. First, navigate to the KubeSpray installation path. Next, define the environment variables required to install KubeSpray. You can find the host name and IP information in the commands at the bottom of the documentation. As you type the command, you should see the output as shown on the screen. After printing out the host name and IP information, the next step is to select the storage where you want to install KubeSpray. As mentioned earlier, Container Platform offers two storage choices, NFS and RUCSF. NFS if you can't add volumes to the node. If you can add volumes, we recommend choosing RUCSF. And if you choose NFS, you need to enter the private IP of the NFS server. Next, we'll install the necessary packages through the shell script, then set up the node configuration KubeSpray installation information, and install KubeSpray through Ansible playbook in batches. First, proceed with the installation through the deploy CP cluster shell script. Next, we'll see how to verify the KubeSpray installation by checking the Kubernetes nodes and the pods in the kube system namespace. You can check your Kubernetes nodes with the kubectl get nodes command. Checking of the pods in the kube system namespace can also be checked with the kubectl get pods. When creating resource by yourself, make sure not to include prefixes shown in the textbook. Part 2. Cluster Installation Demonstration. Let's look at a video of the installation process we've been through so far. This concludes Section 1. Deploying Container Platform Cluster.